of a mean monthly temperature. And I took this from an IB textbook. So if you go to the next slide, here's an example of Cape Town. They took the mean monthly temperatures for each month. So if you imagine in January it's 28 degrees, in February it's 27 degrees, and then you continue on. So what they did is they graphed, here's January, 28 degrees, February, 27 degrees, and they continued this. Okay, you'll notice that the temperature looks like what type of trigonometric function? Sine or cosine, right? So we know it's either a sine or cosine function. It kind of goes dips down, comes back up, dips down, comes back up. And what we're going to do is we're going to try to figure out what the function is. We're going to write the function. We're going to find the amplitude. We're going to find the period. We're going to find the translations ups and downs and lefts and right. Okay? And that's what the next slide is about. So the first thing we want to do is we want to identify, are we going to do a sine or cosine function? So we're going to choose the sine function. So this is here on your PDF. The first thing we want to do is figure out the period. How long is one revolution? So if we go back to this slide, do you believe that this is cyclical for about 12 months? It goes down, and comes back up for a revolution of a period of 12 months. So we want to find the b. So if you remember, how do you find the b in a sine function? 2 pi over b. Well, we know this is 12. So on the next slide, we go back. They say 2 pi over b equals 12. And we're going to take the time to solve it on another problem. I'll kind of go through this. So our b value is pi over 6. So we know our first piece of our sine function. The next thing is we want to find the amplitude, the height. So you remember the height is halfway between the axes. And the axis is somewhere about in here. Do you agree? The middle? So we want to find out what is the height from the top down to that horizontal axis. So how you do that is you pick your maximum temperature and your minimum temperature, and you're going to average it. So you're going to take your maximum, this is on here already, 28, and your minimum, 15. You're going to subtract them and divide by 2. So your amplitude is 6.5. Now let's kind of look at the graph. Does it look like it's about 6.5 here? Looks like that, about here. That's the distance. All right. The next thing is we need to find out how far up are we moving that horizontal axis? What is that vertical shift? So to find that, instead of subtracting the maximum minimum, we're going to add the maximum and minimum and divide by 2. So we take that 28 plus 15, divide it by 2, and we have a shift of 21.5. Let's go back up to our graph again. Does it look like, I put it at 20 because I wasn't sure. The principal axis is at 21.5. So this is our y equals 21.5 up. Then we have our sine function. Graphed out one revolution. Our amplitude here was 6.5. So we found 3 things so far. We found the A, the amplitude. We found the B, which is from the period. We found the D, which is the movement up on the horizontal axis. So it moved up 21.5 units from the original 0 axis. The last thing we need to find is the C, the shift change. And what they've done on this problem is they've identified this point right here, A. And that is the shift. Wherever it touches on the new principal axes, this purple line, this is your A. That's where they're saying the shift happens. All right. Oh, there, we gotta go back for a minute. Did you get your 21.5? All right, so here's the graph again, what I was just talking about, our A value. That is our shift to the right, and how many months is that? This is January, February, March, April, May, June, July, August, September, October, November. So where is that? How many months has gone by? 10 months. And this is the point that touched on the horizontal axis of y equals 21.5. So do we now know all the pieces? They put in everything so far down here. Everything but the C. So what do you think our C is going to be? Positive 10 or negative 10? If here's 0, 0, and we're going to the right 10 months, what is our C going to be? Negative 10, yep. So our A value was our amplitude, 6.5. Our B value was pi over 6. Our D value was moving up 21.5 units. So now we can throw all of the things in. So this kind of explains what we just were talking about, the 21, 10, 20, 21.5. So now we have our finished product equation. What we then could do with that equation is we could make predictions of our temperature at any time. So if we want to go out to 27 months, what would be the temperature? We would plug in 27 months. And for time, we could approximate what the temperature would be.